In case of BCH code we use SI is equal to R alpha I. So in this video we will see how that equation comes. So S is syndromes, I is integer from 1 to up to 2 TC, R is received code word, and alpha is primitive element. So how this equation comes? So we know that Rx is equal to Cx plus Ex. Rx is a received code word which can be a corrected code word or incorrect code word. If Rx is introduced, or if Cx is introduced with error, then it is an incorrect code word. If there is no Ex, no error, then Rx is equal to Cx. So Rx is a incorrect code word, Cx is a correct code word, and error is introduced in the correct code word through channel, or through at the encoder side also, as well as in between the channel. The noise introduced is nothing but Ex. So let us go for the encoder part. So Cx is, you know that in cyclic code, which is also BCH code, is also a cyclic code. So in cyclic code, Cx is equal to mx into gx. Correct code word or code word we obtain by multiplying message polynomial with generator polynomial. Now in BCH code, generator polynomial has roots alpha, alpha square up to alpha raised to 2tc. That means for these values, gx is equal to 0. So similarly for these values, cx is also equal to 0 because gx is 0. So these values alpha, alpha square up to alpha raised to 2tc, that means alpha raised to I, where I comes from or starts from 1 to up to 2tc. So for those values, cx is equal to 0, or those values are also the roots of cx. So we have this equation, Rx is equal to Cx plus Ex. So for x equal to alpha up to alpha raised to 2tc, Rx is equal to Ex because Cx is equal to 0. Rx is equal to Ex. So Ex is nothing but Sx, that is syndrome polynomial. So instead of writing Rx is equal to Sx, we write S subscript I is equal to R alpha raised to I. R x is alpha square up to alpha raised to 2tc, that is alpha raised to I. So this equation we use instead of Rx is equal to Sx. So Cx is Rx is equal to Cx plus Ex, but for x equal to alpha raised to